Students, welcome to our physics discussion, that is physics in a smart way. Today, we will be going through another issue of center of mass. Rather, that is another question, how the center of mass can be used. The number of ways center of mass can be used is numerous, too numerous and too interesting, but we cannot extend our ideas too long. Otherwise, we'll be entering into engineering syllabus and all that. But at your 11th level, center of mass can be effectively utilized in many cases. And in some cases, you can't even imagine the way center of mass will be giving you some specific advantages. Let us say we consider a question in the way of center of mass. We got a stone. A stone is thrown from the ground level. A stone is thrown from the ground level with an initial velocity 50 meters per second. Initial velocity 50 meters per second and an angle of elevation, making an angle with the horizontal, that is tan inverse of 4 by 3. Tan inverse of 4 by 3. That seems to be slightly bit odd to you, but that's a very comfortable angle. So a stone is thrown from the ground level with an initial velocity of 50 meters per second and at an angle with the horizontal, that is, you may say tan theta equal to 4 by 3 or theta equal to tan inverse of 4 by 3. As the stone starts to fly in air, at the highest point, the stone suddenly breaks into two pieces in the mass ratio 1:2. In the mass ratio 1:2, and the smaller piece loses all its speed and falls down straight vertically and hits the ground, where the other piece will land. At the highest point, I am again repeating the question, at the highest point, the stone breaks into two pieces in the mass ratio 1:2. If you desire, you can write it down. At the highest point, the stone breaks into two pieces. At the highest point of its path or of its trajectory, the stone breaks into two pieces in the mass ratio 1:2, and the smaller fragment or the smaller piece loses all its speed and drops down vertically straight, hit the ground. So where the other piece will land, where means how far away from the starting point of the point of rejection will the other piece land, where the other piece will land. It's a question. And as you know, as we have discussed previously, when you are given a question, you must stop the video, give it a pause and try to do on your own. I am proceeding with the solution. At any time you feel like referring to it, you can go into it. You can go and peruse it. Let us say we start with the answer. So angle of projection is 4 by 3, and when angle of projection is given as 4 by 3, you can very easily see tan theta equal to 4 by 3. Tan theta equal to 4 by 3. So from that, we can find out sin theta and cos theta and any other angle. Sin theta equal to 4 by 5, cos theta equal to 3 by 5, sin theta equal to 4 by 5, and cos theta equal to 3 by 5. And when the stone is thrown with such a velocity, very easily we can find our formulas of the projectile motion and can find out its time of flight and its range, or else we may use our common sense and can find out so far as time of flight formula is there, we know that will be equal to 2u sin theta by g. That When you put down the values, 2 is 2, u equal to 50, sine theta equal to 4i5, g equal to 10. Yes, one thing I have forgotten, acceleration due to gravity is to be taken as 10 meter per second square. It's a usual phenomenon. So when you put down the values, we know that it will be coming out as 8 seconds. And when somebody tries to find out the range of the projectile, then the range of the projectile will be 3 into 8, that is 240 meters, or u square sine 2 theta by g, so thereby that is 50 meters. Or else you could have find the time of flight as, if somebody goes for the vertical velocity will be equal to u sine theta equal to 4v5, u equal to 50. So that gives you 40 meter per second. So once you ascertain that vertical velocity is 40 meter per second and the value of g equal to 10, then you know gravity takes 4 seconds to reduce the velocity to 0, because initial vertical velocity is 40 and gravity is 10. 40 by 10 equal to 4. So body takes 4 seconds to go to the highest point and again 4 seconds to come back. So 4 plus 4, 8 seconds is the total time of flight. And if somebody takes the horizontal motion, total time of flight is 8 seconds and horizontal velocity equal to u cos theta. U cos theta is 3 by 5, u equal to 50. So that is 30 meter per second. So that gives you 30 into 8, that is 240 meter per second. So it is not always necessary that one a student needs to remember the formulas and all that. Using our common sense, basic use, and the basic sense of physics, trying to understand physics instead of relying on the formulas, and won't help in such a way, but rather making the things simple, making the things lucid for you, understanding the basics will be helping you. So range equal to 40. If I divide the range into two parts, because at the highest point of its path, that is the middle point of the trajectory, the smaller piece drops dead and falls down straight. So smaller piece hits the ground at the point M. The entire range is given as 240. So from the starting point, the midpoint is 120 and other point is 120. Of course, other point, no, nothing is there or will be there. If the stone would not have broken down, then the stone would have hit it. But our question is where the other piece will land. Where the other piece will land, you can find it in many cases. At the highest point, we can find out the velocity of the stone. Velocity of the stone will be horizontal velocity. Then take the other piece. Then try to find out, use momentum conservation, try to find out the body which is thrown from a height. You have to ascertain the height of the projectile. At that point, that will be around 80 meters or something like that. Count it, the formula is there, u square sine square theta by 2g. So thereby you try to ascertain, and so if we try to follow the traditional procedure, at the highest point we take momentum conservation, because the smaller piece is to lose all its speed. So the larger piece will be considering all the momentum of the entire stone present just before breaking. Now the larger piece is moving in a projectile path. You have to find this height and those things. That will be long issue. That will be a long issue if you go to the traditional approach. But here we follow the idea of the center of mass. Let us say we talk with the center of mass. We are in a conversation with the center of mass at this point. Center of mass will claim that The breaking of the stone is not due to any external effect. Somebody didn't go up there and hammer the stone to break into two parts. So breaking is an internal phenomena, or the breaking of the stone is a phenomena where external effect or external pressure or external stimuli is not required. So thereby the breaking is a physical change which is purely internal. So as a result of that, center of mass won't be changing its original motion plan. The original motion plan of the center of mass was to follow the path of the projectile and to strike the ground here. Strike the ground here at the point F. So center of mass, the smaller path falls dead, larger path takes a path like this, but the center of mass will follow the path which we are showing in red. At the last instant, when the smaller path falls here, larger path falls here, we know center of mass will be at the ground at a point like this. Now, we have not forgotten our last video, the formula that is M1 R1 equal to M2 R2. So if this is R1, that is R2. R2, let us say the larger piece is the ground at a position where at a position. जो समय ଆସିବ ମୁଁ ଜାଣିଛି I'm sorry, I had to pause the video and some private conversation might have entered into it. Okay, so let us continue with our discussion. So we know if the stone had not broken, the center of mass would have taken a path like this. Now the stone is broke. The stone has broken. Center of mass still will be following a path like this. And when the pieces, the small piece lands here, large piece lands here. We assume the large piece lands at a distance. This distance we take as x. So center of mass will be following the path which we have shown in red. We have not forgotten our formula. Now the system is a two-mass system. One mass is M, other mass is 2M. M1 R1 equal to M2 R2. So when you follow the formula that M1 R1 equal to M2 R2, M2 R2, M1 equal to M, R1 equal to 120. This is R1. This is R1. That is 120. Half of the range of the projectile. M2 equal to 2M into R2. We know R2 equal to X. So I'm getting cancelled. 2 to 60. So X is coming out as so to say 60. 60. Okay. So as we got X equal to 60 meters, the total distance from the starting point, we know this distance equal to 240. 240 plus 60, we know that must be equal to 300. So our answer must be 240 plus 60. 240 plus 60 meters, that is equal to 300 meters away from the point of projection. So that is the way the center of mass is used. So the stone breaks into two pieces, three pieces, or many pieces, multidimensionally. It doesn't matter. Center of mass idea can be comfortably encompassed into our calculations, and things can be found out very simply and very straight away. Things can be found out very straight. So that's all on this video. Next we shall be talking on some other topic. So thank you for your kind